Hello everybody and welcome to part B of exercise 2. We are looking at page 25 here. The instructions to this problem are actually at the top of the page. Let's scroll up and remind ourselves. So we'd like to determine whether or not the set is linearly dependent or independent. Okay, and then if it's dependent, to find a dependence relation. Okay, so kind of scrolling back down to this. In this case, our vector space is R3, and we'd like to know if these three vectors are linearly dependent or independent. Okay, so as we know, starting point, kind of going back to our definition, is to form a linear combination of these three vectors and set it equal to the zero vector. Okay, so if we wrote all that out, it would look like plus this. And then we'd ask the question, what is the zero vector in R3? Well, that looks like 0, 0, 0. Okay, and we've seen systems like this enough to know that this can be rewritten in a matrix form that looks like this, where the vectors in our set S become the columns of our matrix. Okay, so 2, 1, -3, -1, 3, 6, and then the right-hand side becomes the vector on the right-hand side. Okay, so what it comes down to is whether or not this system has non-trivial solutions or not. Okay, so we would solve this system, and again, I'm going to kind of de-emphasize the row operations here. Okay, we start with a pivot position up there. We want to get zeros below it, so we could take 2 times the first row plus the third row. Okay, that would lead us to a matrix that looks like, let's see, what would it be? 0, 1, 4. Okay, and then we're kind of done with the first column. Looking at the second column, we've got a pivot position there. We'd like to get a 0 below it. So we could take, let's see, what would work here? -R2 plus R3. Okay, and then this would reduce down to 1, 2, -1. 0, 1, 3, 0. Okay, and then if we take -R2 plus R3, that's going to give us a 0, 0, and a 1. Okay, and the questions are, what are the solutions to this system? Okay, well, let's start by circling our pivot positions. First, non-zero entry in each row. And what would happen if we solved this system? Okay, well, let's see. If we start with the very last equation, read that off, that tells us that C is equal to 0. Okay, then we could move up to the second equation. If we write that out, it looks like B plus 3C equals 0. But if C is 0, that means that B is going to have to be 0, because this 3C just disappears. Okay, and then finally, we go back up to the very first equation. If we write that out, it looks like A plus 2B minus C equals 0. But we now know that B and C are both equal to 0. So those two terms are going to disappear, and we're going to get A equals 0. Okay, so what have we demonstrated here? Well, we just demonstrated that the only solution to this system that we started with is the trivial solution, A equals B equals C equals 0. Okay, that tells us that S is linearly independent. Okay, there's the answer to our question. Okay, but I want to make a comment here because we can really shorten this process, okay, if we think about this a little bit. So, kind of if you think about this a little bit, the fact that we had a pivot in every single column of this matrix that we had, that told us that we have no free variables, and if you think about it, anytime that happens and you have zeros on your right-hand side, you're always going to have this happen. In other words, you're going to discover that all of the variables have to be 0. Okay, so a shorter way to kind of come to the same conclusion that we have here would have been to make the observation that there are no free variables in this system, and the fact that there are no free variables means the only solution we can get is the trivial solution. Okay, so maybe a shorter way to explain this would be just to make the following observation. Since our system has no free variables, okay, again, the fact that there was a pivot in every single column told us that. The only solution is the trivial solution. Okay, S is linearly independent. I'm going to use that abbreviation for linearly independent, just Li. Okay, so as we do future problems, we may take advantage of this shortcut. It's really, we actually didn't need to do this algebra if we remember that the fact that no free variables kind of is always going to lead us to this solution in this situation.